Welcome back to another lesson from Math Above the Influence. We are still talking about functions. Today, we want to work on evaluating functions that are written in function notation. Before we begin, I want you guys to understand what function notation is. All right, so I'm going to use the generic slope-intercept form. Okay? Y equals mx plus b. The only difference between this form and function notation is instead of y, we have f of x, okay? So what this means is, what is y when x is some number, okay? So this whole thing is y. What is y when x is some number, okay? So now what we're going to do is we're going to jump into these examples that they've given us. They want you to evaluate what y is when x is 2 for each of these functions. Now, with this particular standard, IF2, they want students to be fluent in using function notation to evaluate linear, exponential, and quadratic functions. So a linear function, which we all know this, is a function that has a constant rate of change. We can take that a step further and recognize linear functions as having no power greater than 1, okay? So this one would be a linear function, okay? Our x exponent is 1. When we look here, we notice how our x is an exponent. That's an exponential function. And here we notice how our power is 2. That is a quadratic function. So again, this standard wants you as a student to be able to evaluate functions no matter what type of function you are given. So we're going to evaluate each of these three with x being 2. All right. So I want you guys to log into Desmos and work along with me. Pull up that app, go to that website. And we're not doing linear regression, so we don't have to find that little squiggly line. We're going to work with just our equal symbol. I want you to push that plus button in the top, or you can just start writing in the first box that they give you here. And I want you to type everything that you see on my screen. So y equals this equation here. 5 times the difference of x and 3 plus 17, okay? Once you type that, you are then going to press this gear right here at the top on the left side of your screen. Once you do that, it's going to populate a little table. And once you push that table, it should populate these values. So essentially what it's saying is these are your y values for this function when x are these values, okay? So, and we know that this is a function. Remember, we learned in the last video that a function is represented by x values being paired with exactly one y value. So we know this is a function because we do not see any of our x values repeating, right? So, all right. So now that we see what our table of values looks like, it told us to evaluate this function when x is 2. So when x is 2, our function equals 12, okay? So that's pretty simple, right? Pretty simple. All right, so let's look at that second equation. This is our exponential function. So you're going to come right here and begin typing your equation. So you're going to type in the equation that is on your first screen. If you guys can't see it, I'm going to retype it for you. Y equals 1200 times 1 plus 0.04 to the x power. And I'm hoping you guys haven't forgotten when we talked about exponential functions in some of our previous videos, we know that this value is our starting point, right? And in here tells us whether or not we're growing or decaying. We're growing if that value is greater than 1 and decaying if that value is less than 1. But that's not why you're here. But I just want to check in to see if you guys remember. All right. So anyway, we're evaluating this exponential function when x is 2. So when x is 2, y, or our function, is equal to 1,297 and 92 hundredths. Okay? This is pretty simple. All we're doing is plugging and chugging. We're typing it in, and it's spitting out what we need. So we're going to do it one more time. You can click right here in this open space, type in that third equation, this one here. This is a quadratic function. So in case you guys don't see it on your screen, I'm going to write it over for you. Y equals 3x squared plus 2x minus 5. Okay. And then once you type it in, you're going to go to that gear again. And you're going to click on that table that populates. So it gives you your table of values. And we're looking for y when x is 2. Okay. So our function is valued at 11 when x is 2. Now that we know how to do this using Desmos, I just want to show you guys how to do this graphically. Because essentially what these questions are asking us is to substitute the 2 where we see our x. Okay. So we always want to make sure that we're still able to work pen and pencil, figure this thing out algebraically. So I want us to do this together. All right. So when x is 2, what is this function valued at? So first we were going to start with our parentheses, and 2 minus 3 gives us a, -1. All right. And then we have 5 times -1, which is -5. Bring down your positive 17. -5 plus 17 gives us a 12. So our function is valued at 12 when x is 2. So this coordinate would be 2, 12. Now let's take a look back and see if that's the same thing that Desmos gave us. Yep, it is. Same thing Desmos gave us. Let's do the same thing with our exponential function. Let's see what we get. All right, so we got f of 2 is equal to 1200 times 1 plus 400 to the second power. All right, so we're going to start with what is in our parentheses. And we have 1200 times 1.04 squared. Now, when we square 1.04, we get 1.0816. And then when we multiply that times 1200, we get 1297.92. Okay? So then this point would be 2, 1297.92. All right, so let's check and see if this is what we got on Desmos. Yep, it's right here. So far, we're doing good. All right, so let's try our last one. This one is our quadratic function. So remember, whenever we're solving this algebraically, all we're doing is substituting the value of x. Remember, x is our input to figure out what is the value of our function or our output, okay? So we start with our exponents. 2 squared is 4, okay? All right, and we can go ahead and evaluate this. 2 times 2 is 4. All right, and so then we're going to go to our multiplication. 3 times 4 is 12, plus 4 minus 5. 12 plus 4 is 16, minus 5 is 11. All right, so the point here would be 2, 11. Let's check and see if that's what we got. 2, 11. So, yep, we're batting 3 for 3. So let's do some summary and make sure that we understand what we've done here. All right, so for this particular example, they told us that they want us to be able to evaluate functions written in function notation. Remember, function notation is just us saying what is y when x is blank, okay? Function notation is no different than y equals form. The only thing different is instead of y, we're going to see f of x, okay? And that's just going to tell us, or it's going to ask us, what is y when x is whatever is here, okay? So we wanted to be able to evaluate functions. We used Desmos to do this. We went right to Desmos.com or pulled up that app, typed in that equation just as we saw it, used that gear to create our table, and then bada bam, bada boom, we figured out the value of our function. Then, just because we love to go the extra mile, we then evaluated our functions algebraically, okay? That simply means we are substituting our input for x, right? So that we can figure out what our output or y is. And then, just because I love to be extra, we then identify what would that point be on the coordinate plane. What would that point be on the coordinate plane? All right, so I hope that you guys have at least a general understanding of how to evaluate functions as they're written in function notation, okay? All we're doing is figuring out what is that value of y when x is whatever is inside that parentheses. If you have any questions, comments, or concerns, I want you to drop them below. Let's talk about it, because remember, we are on this journey to mastery together. Thanks, guys. Until next time, peace.